get our file ready to 3D print. Um, and the way we do that is we use something called a slicer. So we're going to use a free slicer called Cura. Cura is a very popular slicer. It's open source. It's also free, and that makes it great for our purposes. It supports a lot of 3D printers. Chances are, if you have a normal FDM printer, Cura probably does support it. If not, you can come up with your own custom profile. Um, you can go over here, download it, depending on what computer you have, and we can get that set up. But for now, we'll go back to Tinkercad. So you have your design you made, right? In this case, we'll be using this design. And what we want to do with that design is we want to download it. And you can download it by clicking on the object and clicking export, right? And we can choose three different file types for 3D printing. One of them is an object file, STL, or GLTF. In most cases, we want the STL, and we can just click it here. So, and that's perfect. That's exactly what we need. Now back to Cura. Once you download it, it should show up exactly like this. And when you first setting up Cura, one of the most important things you have to do is, well, you have to select your printer, right? And I'll walk you through that. We have to select the right printer because we have to build within the bounds of this printer. When you create a file on a slicer, it slices the file or the object up into something called G code, and that G code needs certain restrictions. Uh, it needs certain restrictions because G code is not very smart code. It will do exactly as it was told to do, and no less and no more. If you tell it to ram into a space that doesn't exist, it will try to ram into that space that doesn't exist. Or if you try to make the G code go farther than the dimension of your printer, it will try to go farther than the dimension of your printer, and that could cause damage to your printer and even worse too, because when a printer gets out of control, it will just keep going it unless there's a safety feature built in. And some printers do not have safety features built in. Over here, we can see the type of printers they support, like so. For me, I just chose a Creality file, and I just chose my Ender 3, which is really simple, like so. And you click Add. Because it has this profile already, it makes it so much easier. I already have it set up over here. I also have to choose my nozzle size, and the type of filament I'm using. The type of filament I'm using is just some generic PLA. Now that we have that ready, let's go import our object. So we just can click File, Open File, and we can click in from our downloads, our most recent one, like so. And we'll see a model representation of that right here. This is it as it stands. But before we move on to getting ready to 3D print, we need to set it up correctly, right? And one of the most important things we have to do is set up the default printing or the printing temperature of your filament. On your filament should be instructions on what to heat and how high do you heat it. Um, there's a recommended manufacturer range, and we should use that. We should use about the middle of it and experiment to see what temperatures work really well with it. But in most cases, just following whatever the manufacturer tells you to do is perfect and it just works. In this case, it's about 220 and the build plate temperature is about 60 degrees. Now that that's done, we'll do a basic version, a recommended. We can look at the quality settings, which is really the layer height. The layer height affects on how good it will look, or not really how good it will look, but how much layers will we give it. Obviously, the smaller layers are, the less of the difference you can see between the lines, and the more high quality or together it will look. The thicker the lines, the less print time it will take, but the lines will be thicker and it will look low res, so low res. For most prints, it just depends on what your personal preference. I do 0.2 because it's a balance between time, speed, and just detail, and it works out for me. So, and the next big parameter is infill. Infill depends on how much material is inside hollow objects. For example, this square, or inside of this panther, right? There are a couple of things. It cannot be a solid object for 3D printing because it's generally a waste of filament. So in order to change that, we can change the amount of infill. Typically, if you're not going to care about strength um, and you just want it done quicker, I would go for 10 to 15% infill. And it works out that way a lot better. Another big one is supports. In this case, our print doesn't need any supports because, well, let's give a good example. So how does a 3D printer work, right? It's layering plastic on top of plastic on top of plastic on top of plastic. You need supports where there is thin air. So if we look in here, part of the panther's body is in thin air right there. Because of that, it might need a support, but it's not too big of a concern because of how small the surface area is. If let's say we flip this object over here in this orientation, like so, and a lot of the surface area is just floating up in the air, we would need a support. And here's what a support would look like. Once we slice it, we click preview, and we can see how it prints that support. So it starts at the head and it prints those random break-offable supports right over there. Those things are meant to be easy to break off of your print once you're done, but ideally we wouldn't want them. And the reason why we wouldn't want them is because we know that we can orientate this print flat like this and eliminate the need for supports. Because we can eliminate the need for supports, we save filament, we save time on printing those supports, and plus, when you print a support, oftentimes it makes things harder to clean up, and it makes the resolution of your print look worse. Now that we have it with no support, we can see how it prints. Down here, we can see the infill setting. This is what 10% infill setting looks like. If you look over here, the higher the infill, of course, let's say 80%, the more dense the triangles will be. And we can see that as an example over here. Yep, that's a solid plastic at 80%. If you look closely, the triangles have completely disappeared, and that's what's left. At 50%, here's what it will look like. You can see the pattern has gotten tighter, and that's what it will look like. But for this print, since it's an aesthetic print, we just want it at 10% because it saves us filament, it saves us time, and it works very well. You can see the time drop by 2 or 3 hours just from changing that. And it's always important to watch the preview because we want to make sure that there's nothing wrong with our print from slicing it. And we can click down here to watch the nozzle head go around. That's how our printer will move around as it's completing this print, like so. And you can see how that's a problem if we print into thin air because molten plastic is molten and it would just droop downwards. Now that we have found something we like, something we can stick with, we have to go over and double check some important things. We have to check the temperature of our filament, our infill, and in most cases, maybe our speed. But the default speed that if your printer has a profile on here that is given, it's just recommended to go with that speed, even though it's not as fast as maybe you would want it, but it will give you the best result because this is something that has consistently worked. But once we have that done, we just click Save File, and it will save as a G-code file. And that's what we'll put on our printer once we're done. And now we have finally prepared a file for our 3D printer to print.